now going to demonstrate how to hook up and make a measurement with a 6675A, a 6623, and a power supply. We have our Xantrax power supply. We have our 6623 high current range extender, and we have our 6675 automatic DC resistance bridge. Hookups. We have a program in, which is connected to the program out of the DCC Bridge, following polarities. We have positive with red, program out to red, the black over here at RX ground for the program out. We also have the extender in. This wire should be solid copper wire. It comes from extender out, or extender in on the bridge to extender output of the range extender. There is a terminal here for grounding, and what we use is the shield from the wire, because there is an active signal coming through this cable. Current connections. We have our power supply input on our high current range extender. We have heavy cables on here because the power supply can produce 100 amps, and the range extender can measure with 100 amps. And following polarities, we have a positive with red, negative with black. And these connections are actually connected to the back of this particular current supply. They have a high current output on the back, and they have a minimum 30 amp connection current output on the front. And in this particular configuration, we're set up to run capable of running the high current. For connections for our shunt, we have the C terminals are connected to our high current range extender, C2 on the top, C1 on the bottom, observing polarity through to our shunt. C1 is black, C2 is red, and our potential terminals from our shunt come back through to our RX side of our bridge. Typically, while measuring in low ohms, we have a 1 ohm connected to our RS side, and observing polarities, we have the connections through to our 1 ohm resistor. When possible, we always use guard and hook it to the guard or ground terminal on our resistors. And there's an output on our bridge which produces a guard signal. Guard should never be confused with ground and should never be connected to ground, as guard is an active live circuit. To make a measurement in low ohms, we first select setup, then edit, then mode, and we choose I extend, which is the low ohms portion. And we select edit, and we enter our value for our RS resistor, which is 1 ohm. And we go down and we select a value for our RX resistor, which is 0.1 ohm. Then we move down to reversal rate. We select 60 seconds, and then we go down to extender ratio. There are 3 ratios for the high current range extender. We have this selected to the times 10 range, which is good from 150 milliamps to 1 amp. So we're going to select our range extender ratio at 10. And we select OK, then previous, and then previous once more, and then a third time until we see the measure symbol on the first key. We press measure, and then pressing measure off actually starts the measurement. The range extender will click once, the high current relay will actuate, and the ratio will start. At this point, we have no current selected because the current selection for a low ohms measurement has to come from our power supply. I will turn the power supply on. I've already preset it to 1 amp. With the current compliance light LED lit, I can see that I have 1 amp. For the accuracy of measurements, we want to check the actual current drop across the shunt. As this is not a high accuracy meter, we will take a high accuracy digital multimeter and check the actual voltage drop across the P terminals. We can see that we have very close, if not more precisely, 1 amp dropped across this resistor. Even though our actual output of our current supply says 1.1, the accuracy of our digital multimeter is greater, and therefore we can get a more accurate measurement. At this point in time, the bridge is starting to make its first measurement. It will cycle a couple of times in rough null before the screen will start to produce a number. Another option, if you're running into problems or difficulties, is during the initial rough null, before the bridge changes its polarity, is to ensure that the polarity being given to the P terminals of both resistors is the same polarity. We can do this by, again, using our digital multimeter across the P terminals of either resistor or both resistors before the bridge makes a switch in polarity. If both polarities are the same, you're in proper phasing. If they're not, then you will need to reverse the P terminals, and the most convenient way to do this is probably on the RX side.